Welcome to this deep dive. Imagine you are building a massive restaurant empire. Do you invest millions upfront in like a sprawling legacy kitchen, hoping you'll eventually fill every seat? Or do you launch an agile food truck?
Right. Or, maybe just install a hyper-efficient vending machine.
Exactly. In the cloud architecture world, serverless computing abstracts away the building, the plumbing, the electricity, leaving you to focus entirely on the food, which is your business logic. Today's mission is demystifying the Google Cloud Platform serverless ecosystem. We'll help you decode exactly when to use which compute and API service.
Yeah, mapping that ecosystem is crucial because the way we build applications has, well, shifted fundamentally. We've moved away from relying on those giant permanent kitchens to assembling highly specialized on-demand services.
Services that scale the second a customer walks in, right? If we look back at the original massive kitchen, that was App Engine. It was GCP's legacy platform as a service.
Yep. You'd throw your entire monolithic web application into one environment, and Google managed the servers. But, the industry realized pretty quickly that putting everything in one giant pot comes with massive limitations.
Right, because a monolithic application becomes incredibly slow to update.
Exactly. If one part of the code breaks, the whole kitchen basically grinds to a halt. And that vulnerability drove the shift to Cloud Run, which is the modern standard now.
Okay, let's unpack this. Cloud Run uses stateless containers, right? Basically, self-contained mini kitchens that spin up on demand.
Yeah, and it uses standard OCI containers, meaning the container itself is just a standardized digital box.
Which means you aren't trapped in the Google ecosystem.
That is the real power of it.
Yeah.
Cloud Run is built on Pay Native, an open source standard. Think of native as like a universal blueprint.
Okay.
Because Cloud Run relies on that blueprint, you can take your specific container and run it identically on any Kubernetes cluster anywhere. It completely eliminates vendor lock-in.
Oh, wow. And the concurrency model is incredibly robust, too. I mean, a single Cloud Run container instance can handle up to 1,000 concurrent requests simultaneously.
It's remarkably efficient, yeah.
But wait, I have to push back here. If Cloud Run is this massive, instantly scaling buffet that handles 1,000 orders at once without breaking a sweat, why even bother with Cloud Run functions?
That's a fair question.
Because functions just run single-purpose code snippets triggered by specific events. If I have a scalable kitchen handling 1,000 orders, it feels like a step backward to install a vending machine that only hands out one item at a time.
What's fascinating here is that you don't always need a full kitchen staff to handle a simple reflex. Functions serve as the lightweight enterprise glue.
Enterprise glue.
Yeah, they require absolutely zero container management. So say someone drops an image into a cloud storage bucket, or a critical security alert pops up in your audit logs.
Right.
A function acts as an instant automated reflex. It spins up in milliseconds, executes a security remediation, and then instantly vanishes.
So there is no overhead and no wasted resources for a task that only takes a fraction of a second.
Exactly.
Okay, so we have our compute sorted. The mini kitchens and the vending machines are humming along. But how do you manage the absolute chaos of external customers shouting orders and the internal staff coordinating the plates?
That's where directing the traffic comes in.
Right. The architectural guide highlights two distinct traffic directors, API gateway and cloud endpoints.
This is where separating your application code from your traffic management becomes vital. API Gateway is a managed Envoy proxy designed for your serverless backends.
So instead of writing code inside your application to handle, like user authentication or rate limiting, you offload all of that external governance to the API Gateway.
Yes, effortlessly offloading it.
So is API Gateway the club bouncer checking IDs at the front door?
That's a great way to put it, actually.
They stop anyone trying to spam the restaurant with fake orders, and they manage the line outside so the chefs inside can just focus entirely on cooking.
That is the exact mechanism. Now, cloud endpoints, on the other hand, acts more like the internal expediters coordinating between the chefs themselves.
Got it. So like a VIP liaison managing fast internal chatter between microservices.
Exactly. Endpoints is a distributed ESP sidecar proxy optimized for custom GKE or virtual machine fleets. It's built to process incredibly fast, sub-millisecond internal requests using high-performance protocols like gRPC.
Meaning it's not dealing with the customers out front at all. It's just facilitating the rapid-fire, shorthand communication between the appetizer station and the grill.
Which keeps the entire architecture secure and highly efficient. If we connect this to the bigger picture, your front of house maitre d' handles the public chaos, and your back of house expediters talk in a highly optimized internal language.
And this is why you should care about all of this. Picking the correct GCP trigger and execution model up front, whether it's the maitre d' or the expediter, the full kitchen or the vending machine, saves you from some truly painful refactoring when your traffic inevitably spikes.
Yeah, you have to match the underlying architecture to your actual operational needs.
Absolutely.
Since serverless completely abstracts the infrastructure layer, it makes you wonder, are we approaching a future where enterprise applications simply assemble, scale, and route themselves entirely based on organic system events?
With zero human configuration. A restaurant that spontaneously builds its own prep stations the moment a customer gets hungry. That is wild to think about. But until that day comes, just make sure you're picking the right kitchen for the job.